So what I'm going to do is go into the Dynachem menu here in Excel, and I'm going to choose Explore Design Space, just like I showed on the slide a few minutes ago, and I'm going to choose this multiple factors and levels approach, which is effectively a full factorial, and I'm going to say I'm just interested in the endpoints from this reaction. And a little dialog appears then where I can choose the conditions that I'd like to vary, the factors, so the horizontal axes coordinates, if you like. So I'm going to choose reagent or equivalence and temperature, and then I'm going to move to the next screen where it invites me to indicate how many levels of each factor I'd like to study, and I'm going to choose 9 levels of each factor. So it's quite like Mark Hughes's presentation. He did 77, I think. I'm going to do 81, and of course I can optimize the mean and the range and so on here as well, but for now I'm just going to take the defaults. There is an option up here as well to save the concentration and temperature profiles for every single run versus time. I won't do that, but I just want to point out the option to you, and I'm just going to press the run button now. So this then generates in my Excel workbook those 81 additional what-if type scenarios. They don't necessarily correspond with any experiments that we've done. They're just explorations based on the model we've built. And they run quickly if it's a reasonably straightforward model, like many kinetic models will be. And then I get a list of all the scenarios that were run, the experimental conditions. So you can see here we've got, cycling through the reagent levels, and then the slower loop is cycling through the temperatures. So it's just doing that full factorial, an experiment, a virtual experiment at every single vertex, if you like, in the mesh of conditions we've defined. And then the outputs here, the responses, are the final results for each of the things that are of interest to us. So it's substrate, reagent, product, and impurity, all in grams in this case. Now the coloration here is so that you could, if you wanted to, do some quick checks on which of my experiments are above or below a certain level for any of these results. So let's say, for example, I knew I needed to have less than half a gram of impurity. If you just type that in here on the results tab, it will show you the scenarios where you achieved that in blue, and the ones in red are the ones where you didn't. So there are some nice quick ways of finding out the overall behavior of the exploration you've done. But what I'm going to do is just what I showed on the slide. I'm going to say I want to just pick the range where I varied my my input. So I'm selecting column E all the way out to column K. So I'm including the columns where my factor variations are listed, and I'm also then including all my responses. So I'm selecting basically the region of interest on this worksheet, and then I go to the Dynachem menu and I choose Plot Results, Excel Pivot Chart. And what this does for me is just a quick Excel plot. Really, a pivot chart. Pivot charts are actually extraordinarily useful. There's a voyage of discovery, I think, there for anybody who takes the time to understand them. But it's, in this case, we're just using it as a quick way of getting a 3D plot. That wouldn't be one of Excel's strengths. So if I wanted to make a very nice 3D plot, I would copy and paste my results into another tool and make some nice plots there. But for quick work, this is good for getting an idea of what's going on. So here we now have our two factors, temperature on this horizontal axis, sort of near the front of the screen, reagent quantity on the other horizontal axis, and we have a contour plot of the impurity level at the end of reaction. So again, here we have this kind of monotonic behavior, that more reagent, more temperature, they're both bad for impurity in this particular case. And then the way these pivot charts work is you have to have your two x-axis variables selected and then one z-axis or vertical axis variable selected. So once I uncheck impurity here, the graph disappears, but then if I check product, the graph reappears. So now I'm looking at the response surface for product. So for quick work, I think, and getting a quick plot, this is absolutely fine. For more careful, more graphically interesting work, I think you may want to use another tool to plot these results. So here we've looked at product, and you can see clearly there that there is a kind of a happy region where I can achieve a maximum product level, And it's actually slightly easier to see that if in Excel I change the chart type and go for a vertical view. So I'm now looking down on that response surface, and I can see clearly that, say, in this blue region here, which has got a purple violet region on either side, that blue region is where my product is at its peak, in this case between zero point 0.8 and 1 grams. And that's something I would like to take forward in terms of further developing the process.